All right, fundamental theorem of algebra. So we're going to go through how do we use the fundamental theorem of algebra, the imaginary root theorem, and the rational root theorem to help us figure out some information about a polynomial we might be solving for, which can help us to know whether or not we're doing it correctly, whether or not we're finding all of the roots. So you have solved polynomial equations and found that their roots can be, and our possibilities here are integers, rationals, rationals. So integers, rationals, irrationals, and imaginary. All kinds of possibility for the different kinds of roots we can have. The fundamental theorem of algebra describes the relationship between the degree of the polynomial and its number of zeros. The fundamental theorem of algebra describes the relationship between the degree of polynomial and its number of zeros. You can factor a polynomial of degree n into n linear factors. Example, x to the third equals 0 should have 3 roots according to the fundamental theorem of algebra because it has a degree of 3. So they're tied together, okay? The degree of the polynomial and number of zeros. Those, because of this fundamental theorem of algebra, it should be the same, okay? So before we start solving polynomial functions, we need to gather some information about them, right? And so we're going to use this process, these little paragraphs, to help us. So start with these first 2 examples. See if I can fit them in here. Okay. So this first example, x to the third plus 2x squared minus 4x minus 6 equals 0. By the fundamental theorem of algebra, how many complex roots should this function have? Now remember, complex includes all of the roots, rational, irrational, or imaginary. So how many of all of the kinds of roots? That's what that means, complex, all of them. How many of all the different kinds of roots should this function have? The answer is 3. How do we know that? Because the degree is 3. Okay, the degree is 3, x to the third. Okay? By the imaginary root theorem, how many imaginary roots could this function have, and how do you know it? Well, this particular imaginary root, this particular function, imaginary root theorem, tells us that it could have 2 or 0. And you're saying, how did you know that, 2 or 0? So let me explain to us. Whoops, I should have wrote that up here. Sorry, 2 or 0. And how do we know that? Let me explain to you how you know that. Remember that imaginary roots happen in conjugate pairs, right? So imaginaries happen in conjugate pairs. Oh my goodness, I can't spell. Conjugate pairs. Conjugate pairs. Okay? So if they happen in conjugate pairs, and just for a minute, let's just think about this off to the side. So let's say I have 4i as one of my roots. I know, because it's an I, an imaginary root, that I have both positive and negative 4i, so that would mean that that's 2 roots, right? If I had 2 sets of imaginary answers, let's say I had plus or minus 3i, but then I also had 4 minus 2i, and I also need 4 plus 2i, right? If I had 2 sets of imaginaries, then I would have to have 4, right? I could have none. If I had 3 sets of imaginary, I, 2i, and 7i as my answers. I need the plus or minus of both of them. That gives me 6. So I know that when I'm looking at the number of imaginary root theorems, they have to happen in pairs. Okay, so 0, 2, 4, 6, 8, they have to go up by 2s. Those are my only possibilities. I can't have an odd number. So have to be evens, right? No odds. And the other thing is, I know that because there's x to the third, my possibility is that there could be 2 imaginaries and then 1 rational. That's a possibility. I'm not saying that that is exactly what is going to happen. Maybe all 3 of them are rational answers, but I could have 2 imaginaries and 1 rational. Okay, so my possibility is 0, no imaginary roots, or the maximum of 2 in this case because it's an x to the third. I can't have 4 roots if it's an x to the third function, so I can stop going up my list and telling those possibilities. Okay? The same case happens for the rational root theorem, so to speak. How many possible roots could this function have? This is asking me rational. So this is our whole numbers, no radicals, no imaginaries, nothing. This is the first thing that we did, where we did factors of C divided by factors of A. Okay? So if we look at that in this particular example, and it says how many roots could we have, let's think about it. We could have, remember, factors of C, so plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. Those are all my factors of my constant, divided by factors of my A term, or my lead coefficient, plus or minus 1. So my answers are going to be positive 1 or negative 1, positive 2 or negative 2, positive 3 or negative 3, positive 6 or negative 6. So how many possible rational roots could this function have? The possibility is that it could have 8. Okay? So maybe 8. Now we already know there's no way that it could have 8, but off the top of our head, this is what our possibility is, right? And then we go through and we test them and we find which one's an actual root. So being able to look at your function and think about these things beforehand is going to make you know that when you get to the end, what your root should look like and whether or not you've done it correctly. So let's look at example 2 and see if we can do this one as well. So fundamental theorem of algebra, how many complex roots should this function have? So altogether, how many roots should this function have? The answer is 4 because it has a degree of 4. Okay? Imaginary. So again, they have to happen in pairs because they are conjugates, right? So I might have none. I could have 2, and I could have as many as all 4 of them being imaginary, 0, 2, or 4. Those are my possibilities. And then my rational root theorem, how many of these could I have? Well, let's look at what C is. C is 3. So plus or minus 1, plus or minus 3, over, and then my A term, my lead coefficient is 1, so plus or minus 1. So my answer is going to be positive 1, negative 1, positive 3, or negative 3. So I have a possibility of 4. 4 possible roots. Okay? So that's how you do that. That's how you use them, and that's what those are used for. The next video is going to be taking an example and solving it out and finding roots, maybe not necessarily doing anything other than what we have been doing as far as solving the function, and the only other thing we're going to ask you to do when you're done is classify what your roots are. Are they rational? Are they irrational? So in the last lesson, we're just helping you figure out what the roots are, get those roots. Now we're saying, go ahead and get those roots, but then classify them for us. Are they imaginary? Are they rational? Are they irrational? So do they have a root in them? So we're going to do that next.